Hello everybody, welcome to my YouTube channel. This is Shiva Ravindra. Today I am going to explain useful SAS techniques in efficacy analysis for oncology studies. So this is the class 10. So previous 9 classes videos you can find the overview about endpoints and data collections, adverse event reporting, tumor measurement, under-assist criteria, oncology specific domain explanation, censoring and confirmation rules, event-oriented analysis, efficacy analysis, special statistics like objective response rate related table along with the code you can find in the previous 9 classes, and this 10th class I am going to explain you the time to event. Okay, time to event related table how to create. Okay, so this is the time to event related table mock shell. Generally oncology studies in the time to event table they are expecting like median and p-value and hazard ratio related stuff. So in the class 7 I have explained the procedures which are helpful for the analysis in that proc life test and proc reg etc we use to determine the efficacy of the content. Okay, so please go and watch the class 7 video as well, and how to create this table step by step we'll see. So these are Adam cases. So after that one, data. So I merge with the ADTT data set. So I just take from the, so actually you have TRT01P here, but I am considering that treatment variable from the ADSL. So if it is a correct, you can use this one. Otherwise, we can take from the ADSL having the exact treatment information. Okay. Yeah. After that one, so you can look at here. First, they will ask median and p-value and hazard ratio. Okay. So first one, median. So this purpose, I am using the proc life test. Life test. So the data set name is ADTT. Okay. So time here we have to select the val versus sensor variable. Sensor 1. Okay. And strata treatment y. So this information you will find. So we'll check with this. You will check the procedure related information in the proc life test. Okay. So already explaining this here. So proc life test related log rank compare with the OS and PF treatment. So here you can see strata 0 and strata 1. So if you are putting 0 nothing but, so 0 is a censored, 1 is the event occurred. So we are checking the event related TTE, right? So that is why we are putting the 1 here. Okay, if you are putting 0 means time to event table, the censoring information indicate 0 is censoring. Okay, so if you are putting 1 in the sense, so that is events related time to event subjects we are taking into the consideration. Okay, yeah. So once we run, yeah, here no output destination is active, like that we will give. So to get the procedure related backend outputs what it created, ODS listing, close, and below you will write ODS listing. Okay, so if you are write like this the ODS So you will find what are the backend data sets created, you will find in the log window. You will see here. Oh, okay, so let me close the SAS and again open, because sometimes what happen if you previously run something, so it again creates a problem. So I just stored the program in. Yeah, so now you can see everything was printed here, even along with the graphical representation of proc live test also it will create. Okay, so if you want to see the backend data sets creation, so here we are not getting, but here you can see. Yeah, here you can see quartile information was there here. Okay, so quartile information was there here. So the backend data set, it should be shown here, but why it is not showing? No destination is active. So backend dataset name should be present. So in that backend dataset, so the dataset name output quartile, the dataset which created quartiles containing the information. So just I am giving the dataset name as quat. Okay. So next ODS output close. So here the data set was created. The backend data set name is quartile. Actually, it should be shown here, but I don't know what is the issue with this no output destination. So what are the backend data sets are created? ODS, tracer and tracer. Okay, sorry. Let me try with this one. ODS, tracer, ODS, tracer. Okay, by writing this one, so you will find the data sets which created at backend. You will see it in the log window. See here, okay, quartiles is the data set containing the survival distribution. So that is why we return the quartiles data set. We make the information get into the work library quad data set. Okay, so quad data set now containing, so percentile you can see 75, 50, 25, and second treatment 75, 50, and 25. So what they are asking here, you can see here the mock shell, they are asking Marshall asking median. So median is nothing but 50%. Okay. So that is why we just filter here itself where this percentage median nothing but middle of the value. That is why we are picking 50%. Okay. Now we can see the first treatment 50% the values lower and upper will you can get. Okay. Now this data set take outside. Okay, and just keep the variables which are required. You can not include unnecessary variables. TRT01PN, and here you will find the estimate and lower limit, upper limit, and so lower 95% confidence limit and upper 95% confidence limit. So you can see lower and upper estimate. You will see the mark shell, what they are asking median, first the estimate, lower and upper value. Okay, that is what we are going to represent in this place. Okay, just concatenated these two information along with this one, and you will represent this information into this first line. Okay, so once we get the values, you already know how to concatenate and how to represent. Okay, so next value is the Hajar ratio. Yeah, so here you will see the backend data set. You will find the quartiles. Okay, and why this is not required, I think. Sorry. Yeah, here you can see the log rank related p-value was there. So if they are asking Wilcoxon, so you will represent this as a p-value. If they are asking log rank, this value you can represent as a p-value. So here, so home test is there, right? So in this, you will find the p-value. So here itself, you can also see here test of equality. So each and every backend data set name was created here. So in this home test related, yeah, so home test related data set containing the p-value. So here itself you will write ODS output home test equal to, okay. So I just given the value p-value. You can see the p-value. Yeah, so p-value, 3 p-values are there in this by using the proc frag. Okay, proc live test. So if the statistician want to use the lag rank, so we can use the lag rank. Otherwise, we can use what are the Wilcoxon. We can use the Wilcoxon. So data pval set pval. So we want to use only the test equal to log rank. Okay. So keep, even this value you can take. Okay, probability. So p value. So this value you have to represent in this table. So this place. Okay, treatment comparison is there, right? So you will keep this value into that place. So this value you have to represent this place, and p value done, median also done. So A treatment, B treatment, both the values you will get in the quad one, right? So first treatment, second treatment. Just you transpose, first concatenated this two and transpose and represent this first treatment place, second treatment place. Third one, hazard ratio. So how to get the hazard ratios values? So by using the proc frag procedure. Okay. So just I'm copying this entire procedure and place it here. And in place here, you will write the procedure proc frag. So data equal to ADTTE, and class treatment wise we are doing the analysis, and model. So here the eval and the sensor event based is depending on the treatment by method ties equal to the procedure discrete. Okay, so risk limit. Hazard ratio equal to hazard ratio TRT01 PN and run. By rating this, you will find so parameter estimate. So you will take this into outside. So parameter estimate, I just given the data set name as Hajar ratio, right? So HZ data. You will find here the information. So here what we need to represent, so Hajar ratio and lower and upper. So these are the three values, lower CL and upper CL, and this is the so the value, open and closing bracket, you need to represent these two values. Okay, these three values you can take and parameter, and you will find here you can see 0.2537 and what we get 22. So this p value by using the proc life test and Hajar ratio you will get by using the proc frig method. So you can customize these three data set and represent the values in this. So this is the uh, important oncology table for time to event. So by using these procedures, you will get the Hajar ratio and p-value median for time to event most of the times. Okay. So thanks for watching video. So you will find more videos in my YouTube channel. Please subscribe my YouTube channel. Thank you.